Hello everybody, today I'm going to teach you how to add and subtract fractions with unlike denominators. In our previous video, we learned how to add and subtract fractions with like denominators. Now we're going to learn how to add and subtract fractions with unlike denominators. Before we get started in the adding, we have to have some review. So here is a reminder. Our numerator is the number on top of the fraction, and the denominator is the number on the bottom of the fraction. The denominator tells us how many parts the whole has been divided into, while the numerator tells us how many parts of that whole we are talking about. Now that we've got that review out of the way, let's get into the adding. So, when you add fractions with unlike denominators, you have to find the least common denominator, known as the LCD, of the two fractions. Then, after finding the LCD, you have to convert both fractions into fractions that have the LCD as a denominator. In one of our previous videos, I had talked about how to write equivalent fractions, which is converting fractions. Then, after you convert those fractions into fractions that have the LCD as a denominator, you add the two fractions normally. Just like we did in the previous video, you just add them like you add fractions with like denominators. And believe it or not, subtracting is the same method as adding, except you subtract. You don't add, obviously. You find the least common denominator of the fractions, then you convert the fractions into fractions that have the LCD as the denominator, and then you subtract the two fractions normally. So I think that is pretty clear on the method, but you may be wondering, how do we find the LCD? You've never heard of that maybe. So, just in case you don't know how to find the LCD, I will teach you. There are two different ways to find the LCD. Let's go over the first way. First way is you line up the multiples of the two denominators on top of each other, and then look for the first number that they both have in common. In this example, we have 2 and 5, two different numbers. We write out the multiples of each one. For number 2, 2, 4, 6, 8, 10, 12, 14, and so on and so forth. For number 5, it's 5, 10, 15, 20, 25, and so on. Now, we carefully look at each number and see if any of the numbers have a common multiple. We look and we see that they do, 10 and 10. They both have 10. Which means that the least common denominator of these two numbers, of these two fractions, is 10. Now this method is very easy and very good for finding the least common denominator of small numbers, such as 2 and 5. Those aren't big numbers. Now here, for number 2, for the second method, this method is more ideal for numbers that are larger. Now, 10 and 6 aren't that much larger than 2 and 5, but we just use that as an example. But for much larger numbers, let's say if you were to find the least common denominator of, 34 and 16, writing down each multiple would take a long time. This method would be easier. Now, this method is to find the prime factorization of both denominators. Then you multiply the common factors and multiply everything else. So, if our two numbers 10 and 6, you list out the prime factorization. For 10, it's 2 and 5. For 6, it's 2 and 3. Now, when I mean you multiply the common factors, you don't multiply 2 times 2. These two numbers, 2 and 2, you just bring them to 1, 2, since they're common. You do not have to multiply them. So you have 1, 2, and you multiply everything else by it. Our other two numbers are 5 and 3. You write 5 and 3. So 2 times 5 times 3. Let's break that down. 2 times 5 is 10. 10 times 3, 10, 20, 30. Which means the least common denominator of 10 and 6 is 30. Now, let's do some practice problems. Here are some practice problems. We have one with addition and one with subtraction. I will demonstrate both methods that we learned about to find the least common denominator. This first one, I will use the first method. We have 2/5 and 1/3, which means our two denominators are 3 and 5. Let's list out their multiples. For 3, we have 3, 6, 9, 12, 15, 18, and so on and so forth. For 5, we have 5, 10, 15, 20, and it goes on. Now let's look at these numbers closely. So 3, does this set have a 3? No. 6, nope, doesn't look like it. 9, no. 12, there's no 12 in the 5s. 15, oh wait, 15 does. There's a 15 here and a 15 here, which means the LCD is 15. LCD is 15. Now we need to convert the fractions. So we convert 2/5. We remember how to convert fractions. We know 2/5, the numerator has to be something, you need to multiply 2 by the same number, you have to multiply 5 to get 15. Now 5 times 3 is 15, which means you need to multiply 2 times 3, because remember, what you do to one side, you have to do to the other side, and you get 6, and you have an equivalent fraction. Now let's do that for 1/3. If we do that for 1/3, the same way we have the denominator 15, you could tell that 3 times 5 equals 15. Now we also have to multiply 1 times 5, which means we have 5 over 15. Now all is left is to add those two numbers. 5 over 15 plus 6 over 15. Now 5 plus 6 equals 11, and we leave the denominator the same, which means that this is our final answer. 2/5 plus 1/3 equals 11/15. Now, let's move on to subtraction problems. We have 5/6 minus 2/4. Let's do this problem with method 2. Let's lay out the prime factorization of 6, 2 times 3, and the prime factorization of 4, 2 times 2. And we see that 2 here is common, which means we bring it out, and we have another 2 and a 3, which we add to the equation and get 2 times 2, which is 4, and multiplied by 3, that is 12. Which means our LCD is 12. Now the conversion awaits. 5 over 6 to something that has a denominator of 12. We know 6 times 2 equals 12, so we need to multiply 5 by 2 as well, which gives us 10. So 10 over 12 is one of our fractions. Now we need to do that for 2/4. 2/4 equals something with the denominator of 12. Now I know 4 times 3 equals 12, so I multiply 4 times 3 to get 12, right? So I need to multiply 2 times 3 to get an equivalent fraction, and 2 times 3 is 6, which means that my equivalent fraction is 6/12. Now we need to subtract 10 over 12 minus 6 over 12. We subtract that 10 minus 6 equals 4, and you leave the 12, you leave the 12 over here as you should, and you get 4 over 12 as your final answer. Now that was how to add and subtract fractions with unlike denominators. I hope you understood this explanation and learned something new. Goodbye.